All right, ladies and gentlemen, we're going to go through and we're going to talk about this last part 4 of 8.1.5. Up until now, we've talked about changes in density, we've talked about changes in heat, we've talked about expansion and contraction. Now we get to go through and talk about how states of matter are impacted by heat. On this graph, we're going to go through and we will show, oh, oops, we will go through and we will show how when we change the amount of heat in an object by putting it on a hot stove, there will be changes at times in the temperature. There will also be times where there will not be changes in the temperature. Getting back to math class, whenever we see a flat line, this is called a zero slope. This zero slope, during the zero slope, we are boiling or we are going from a liquid to a gas. During this zero slope time, we are going from a solid to a liquid. So we need to remember there will be times where the temperature does not change. And that's going to be when we see these flat lines on our graph. So I need you to remember temperature isn't the same thing as heat. If you've been taught that, then you've been lied to. But you need to remember temperature is similar to heat, but it's not the exact same thing. In a similar way that squares are similar to rectangles, but not all rectangles are squares, or not all squares are rectangles. I can't remember the specific one. You can ask your math teacher about that. But just like not all shapes are the exact same, temperature is similar to heat, but heat is not the exact same. On this one, we're going to say that because we have a flat line right here, we have a zero slope. Or the flat line means the temperature is not changing. You would have the same temperatures, 0, 0, 0, 0, until the ice has melted. Once the ice is melted, boom, you're going to see a big change in the temperature. And we know that because we've got this really big positive line. Right here, we've got another example of zero slope. So if the line is flat, it means that the temperature isn't changing. The temperature doesn't change until the phase change is complete. Then it's going to shoot up. And then it's going to stay flat. It's vaporizing. And then it's going to shoot up. So we're going to be looking at this throughout our lab. At this point, by watching the video, you've either done the lab or are about to do the lab. Okay, question. If the line is flat and temperature isn't changing, well, what is changing? Well, we can go back to our graph and we can look right here. We've got a solid, and by the end of this phase change, we've got a liquid. Then we've got a liquid, and at the end of the phase change, we've got a gas. I need you to understand a couple rules. You can only change one thing, but the other thing has to change. So, right here it says, and I'm going to have you guys watch this right here, this graph. You can't change the temperature if you're changing the state of matter. So, if the state of matter is going from a solid to a liquid, the temperature is not adjusting. Then, as soon as this ice is done melting, the temperature is going to go up a lot. The reason why we have a picture of ice right here is, well, when Wads is drinking a Diet Coke, he likes to have a lot of ice. The reason why I have ice here is because my temperature can't change while I am changing the state of matter. So imagine it's a hot day, imagine it's a hot classroom, and I've got my Coke. My Diet Coke is not going to heat up until all of the ice has melted. So that's why we have ice. We're using all of this heat, we're taking all of the heat until this ice is melted. And then at that point, sure, your soda is going to skyrocket. We're going to see this big change in temperature as soon as we've completed a state of matter. So, in closing, we can't change the temperature while we're changing the state of matter. So I can't have a rise in temperature if it's melting, and I can't change the state of matter if the temperature is going up. So it works both ways. Right now, hold on, please, not right now, okay? Right now, we've got liquid, and it's going to stay liquid until we go through and reach a certain point. So no changes in temperature right down here. But while we have no changes in temperature, we have an increase, or we have a change in phase. Right here, we have a change in temperature, but we don't have a change in the state of matter. The heat energy is always changing, but we can't change the state of matter like this ice and the temperature at the same time. I hope this helps. This has been 8.1.5, part 4. Thank you so much.